right, guys, this is objective 2.1b, and our topic for today is using our transformations and applying them to graphs. So yesterday we were just describing them when we looked at an equation. Today we're going to actually graph them. So you will be successful when you can transform a given function using the equations. So here in this section of your note page, I am going to leave it for you to put any notes that any additional information that you want to put there. You have some space to do that. And you're welcome. And I'm going to model what I'd like to see on your homework. So first of all, what I would like to do is I would like to change this problem. Instead of doing the parent function of the parabola, I would like instead to graph the f of x equals the absolute value of x. And I would like to stick within the domain from -3 to 3. So it is very similar to what I'm asking you to do for homework tonight, except your homework tonight won't be an absolute value. It'll be a different function, but it's already drawn for you. Okay, so we're going to do that. So we'll be graphing the parent function absolute value and then the transformed, the y equals f of x on the same set of axes. So first, understand that I will graph my original in black, and I will graph my final, my transformed, in red. Any intermediate graphs will be done in dashed green, intermediate. If I have any, like a double transformation. All right, so we're going to start off on the first graph, graphing the absolute value of x, starting with x is -3. So if x is -3, what's y? Absolute value of -3 is? Absolute value of -2 is? -1, 0, 1, 2, 3. Okay. So there's our original function before the transformation. Okay, so let's take a look at our transformed function. We're going to graph the same function shifted around or transformed. So I have two transformations, so I'll be doing my intermediate transformation, the horizontal action, in green. What am I going to do? Push the graph which direction? I'm going to push all the points right too. So let's do that. Starting here. Everything's shifting to the right too. Which, by the way, is changing the domain. Because this is not my final graph, I'm going to graph it in a dashed line. Okay, and then I'm going to switch to my final transformation, which is out here, +1. That means I'm going to do what to my graph? Push it up 1. So all these points are going to shift up 1. God bless you. And since it's my final graph, solid. All right, so if you do a key on your homework, I would like to see it color-coded. So at least have a pencil and a color when you're doing your homework. And give me a key so I know which is which. Otherwise, I will require you to go, this is y equals the square root of x, and this is y equals f of x. Every time. You're either going to label every one, or you're going to color code and give me a key so I know which graph represents which part of the instructions. Let's go again. Parent function within our domain restriction. Okay, How many transformations does this graph require? 1. And is it a vertical or a horizontal transformation? Vertical. Ooh, okay. So what is that? What kind of transformation if it's 2 times y? It's a stretch. And we're going to multiply all of our y's times 2. All of our y coordinates times 2. Okay. So it's vertical. So we're multiplying the y. All right. So all of our y's are going to be stretched times 2. So let's start with this y. This is y equals 3, right? Yes? Times 2 is? So we got to move it up to 6. This y is a 2. 2 times 2 is 4. This y is a 1. 1 times 2 is 2. And then this y is a 0. 0 times 2 is still 0. Then the 1 times 2, and the 2 times 2, and the 3 times 2. And look at that. That is a vertical stretch. So you'll notice that what happened was the domain from -3 to +3 didn't change because there was no action on the horizontal. But what happened to my range in this one? My original range was from 0 to 3. Yeah? Right? What was my new range? 0 to. So did the range double its size? Yeah, because you stretched the graph vertically times 2, so the range doubled in size. You don't have to mark the ranges or the domains, by the way. I'm just pointing out some connections. All right, going back to my original color and regraphing the parent function within our restrictions of our domain, -3 to 3. And why do I ask you to keep doing that? Because I really want you to know how to graph the parent function of the absolute value. Like I want it tattooed on your brain. Like you see it and you don't even have to think about it. You just graph it. All right. How many transformations do we have in this function? 2. All right. So we have an intermediate. That's horizontal. Horizontal what? Is it a stretch, a compression, a shift? What is it? It's a compression. What are we multiplying our x by? Times a half. That's right. Because remember, you have to multiply by the reciprocal when you're working in the parentheses. So all of our x's, we're going to cut in half, or multiply times half. So this is x is -3. Cut that in half. What's half of 3? -1.5. All right, so I'm going to shift it into -1.5 and put, but the vertical didn't change, just the horizontal. Okay, -2, cut it in half. -1. -1, cut it in half. -half. 0, cut in half. Still 0. 1, cut in half. A half. 2, cut in half. 1. 3, cut in half. 1.5. Okay, this is an intermediate, so just dashed. Not our final graph. Okay. So now you've got an example of a horizontal compression. I think that's a good lesson. Okay, let's go to what else are we going to do? What's that -f? What's that mean? It's a vertical reflection. So we're basically multiplying all your y's times -1. But if we're just reflecting it vertically, can't we just flip them down? Yep. Take all these points and flip them upside down. You, of course, could also multiply all of your y's, because it's vertical, times -1, and you will see that that will reverse them down below the x-axis. Notice what happened to your domain from original. Your domain started at -3, 3. And what happened after on our final? What's our domain on the final? Where am I on my x? Isn't it -1.5 to 1.5? What happened to my domain? It got cut in half. Why? Because I compressed the graph horizontally by half. So it cut my domain in half. It's important to note. Okay, here we go. D, parent function within our domain restriction. I don't like that. I'm going to do it again. Okay. How many transformations does this graph have? 1. And it's a horizontal. It's in the parentheses. So it's a horizontal what? It's a stretch. Times what? So we're going to multiply all our x's times 3. So let's start with this -3. That goes to negative. Okay, that's way off the graph. Let's do the -2. -2 times 3. -6, right? And -1 times 3. -3. 0 times 3 is 0. This x is 1. We're going to multiply that times 3. This is 2 times 3 is 6. And then, of course, it's way off the graph. I'm not even going to graph off the graph. Look at that stretch horizontally. Our domain tripled. Now it's from -9 to +9 because it stretched your graph horizontally by a factor of 3. Okay, last one. Original. Oh my gosh. I'm really having a hard time with my pen today. I only have one transformation, and it's a vertical transformation. What am I doing? Is that a compression or a stretch? That's a compression times a half. So all of our y's we're going to cut in half. So this y is -3, cut it in half. -1.5, yeah? This y is a -2, cut it in half. And this one's a 1, cut it in half. 0, cut it in half. 1, cut it in half. 2, cut it in half. 3, cut it in half. So that's a vertical compression. So you can see what happened to the range. It got cut in half. It went from 0 to 3 to 0 to 1.5. Okay, so it's just pushing the points vertically down, compressing it. Stretching would be pulling it up. Okay. All right. So now that we've done that, let's talk about this last one. So you have the graph of f, which is graphed on your paper. And I'd like to know if anybody remembers. That's a parent function, what function it is. Y equals the square root of x is exactly right. So that's your parent function, which I believe I labeled as the function. Okay, and then you have a, which is graphed here, I believe, correct? And it goes like that. And I'm asking you to write the equation of a. So let's talk about what happened to a horizontally first. What kind of shift? Horizontal. Shift. So horizontal, let me do it in red. I'm just going to write horizontal actions. So it was left 1, and also, what else had happened? It had a reflection, right? So it reflected. Okay, so that's a reflection. So this is happening on the horizontal. Left 1 and reflected. Does it have a horizontal compression or a stretch? Look at the difference between this point and this point right here. How far apart are they? 1 horizontally. How far apart are these points? 1. So there's no horizontal stretch, no horizontal compression. Okay, so those are our actions that are happening inside of parentheses. Now let's talk about our vertical actions. Okay, what kind of stretch is this? Originally it was up 1. Now it's up 2 and up 2. So that's going to be times 2. And then it also has a shift, right? So times 2 and up 2. So when we go to write our equation, our vertical times 2, right? So 2 times, and I'm going to go ahead and write it in square root, and plus 2. So those are our vertical actions happening outside our square root. Now let's go talk about what's happening inside our square root. We have a reflection on the x, so that's a negative x. Okay. Now all of you are going to want to tell me that I should write plus 1 right here, because it's a left 1, right? And we always go opposite, except when we have a reflection. That's a reversal. And that reversal means we're actually going to go left 1. Okay? So maybe make yourself a little note that this reversal on the reflection causes this to be exactly the same thing as happened on the graph. It went left 1, so we go minus 1 because of the reversal. If there's no reversal, then of course stick to the regular rule. Okay? And then what I'd like you to do is I'd like you to do the other one, work with a partner. And then I'll show you here on Desmos in a little bit what both of the equations are. Okay? Okay, guys, so there are the 2 equations that I asked you to write. So your second equation should have been y equals square root of 2x minus 1 minus 4. Because it had a horizontal compression times a half. The points got closer together horizontally. You shifted it to the right 1, and then you pushed it down 4. So that would have been the correct equation for the second one. On your homework, I'm not asking you to write equations. I'm just asking you to graph transformations. So again, for a reminder, for those of you watching the video, problem 39, A through J.